Today we are going to prove a general result. What does it mean? This result is true for any triangle under the sun, any triangle that you can think of, obtuse or acute. This result will be true for all the triangles. What does this result say? The sum of the medians is going to be less than the perimeter. Now, what does a median do? Median is that line segment which connects any vertex to the midpoint of the opposite side, which means BD and DC are equal in measure. Now, how are we going to prove that? We are going to prove that this median here, the median from A, two times of it is going to be less than the sum of the sides which have created this angle A, which is what? AB and AC. So this again you can see it is a general result. This can be proved for the other two sides also. From the other two sides also, if you draw any median, say suppose BF. Now this median BF from B, two times of it is going to be less than the sum of the two sides which has come together to create this angle B, which is what? BA and BC. So that is a good thing about the general results, that you just have to get one and then you can deduce the other. You just have to prove the initial result, the first result. And how are we going to prove that? We already have AB, we have AC. What do we not have? We don't have 2 times AD. So what we do not have, we will construct it. What we are going to do is extend this AD to a point E in such a way that these two are equal in measure. Now, what did we do? We extended AD to a point E such that AD and DE are equal in length. Now, join BE. You will get a beautiful triangle. We can prove that these two triangles are congruent. How are we going to prove that? The way we have constructed, we can see that AD and DE are equal. And what is D? D is the midpoint of BC, which means what? BD and DC are of equal measure. And the third one, which criterion are we using? We are using this one, SAS. Two sides and the angle between them. We have got two sides and the angle between them is what? They are vertically opposite angles, which means what? These two are congruent triangles. And what do we know about congruent triangles? Each of their corresponding angles are equal and each of their corresponding sides are equal. Now, corresponding to CA, the first two vertices, what do you have here? You have BE. You don't even have to look at the picture. You just have to write the names right. Now I have to warn you about something very important. When you write the name of similar triangles, congruent triangles, please be careful. Make sure that the corresponding sides and the corresponding angles coincide. For that, the first name you can write whichever way you want. Now, instead of BED, I can even write it as BDE. But then I have to make sure that the next name, the name of this triangle, corresponds. How do we make it correspond? Now BD, and we know that it is the same as DC. So we can write DC this like this also. But what do you notice? These two angles are same, which means the place where D comes here, that same place D should come here. So you can't write it as DC. Instead, you have to write it as CD. Now look at the third side. What is the third side? It is AD and DE. You have DE here, so DA should come here. So make sure that you write it in a way that the corresponding sides are equal and the corresponding angles are equal. Once you write the name correctly, once you get that correct, you don't even need an illustration. Even without the illustration, you can see that BD and CD are equal, DE and AD are equal, and BE and AC are equal. So that is what we needed from this. Now, this is what all that drama was for. We needed to prove that BE and AC are equal in measure, or in other words, diagonally here we have two equal line segments. And now look at this huge triangle ABE. What are its sides? Its sides are AB, BE. The third side is AE, but I have written it as 2 times AD because that is how we constructed that line DE. Now, what does the triangle inequality say? The sum of two sides of a triangle is greater than the third side. How do you choose? Which one do you put in the lower side? For that, look at your question. Your question needs median in the lower side and perimeter in the higher side. So where you see the median, put that in the lower side and put the other two in the bigger side. But then what did we prove? We proved that BE and AC are equal in measure. So this is the result that we needed. We just have to prove it for A. Then if the other two medians, let me take them as say BF and CG. Now, for the other two sides, you don't have to reinvent the wheel. You don't have to keep doing the same steps again and again. We can see the pattern here, right? Each one of this inequality deals with one particular vertex and the line segments passing through it, the median through it, and the two sides of the triangle through it. So here it was A, here it is B, and here it is C. You have the median passing through it and the two sides touching it. So these are the results we are dealing with. We just have to add all the three. Now we have denoted the sum of the medians with the alphabet M. So here you have M. Here you can add each one of this. You can see 2 times AB, 2 times CB. Everything is 2. So that you have 2 times perimeter. Divide throughout with 2, then you have your required result. So this is the result that we needed to prove. That is all for today. Assalamu alaikum.